All right, we're going to go ahead and get going with ATP, adenosine triphosphate, the energy currency of our body. And we can create it from glucose and from fat. So we're going to go ahead and start off with ATP production from glucose. ATP production from glucose has three steps, three main big steps: glycolysis, the Krebs cycle, also known as the citric acid cycle, and the electron transport chain. Let's go ahead and start and look at glycolysis. All right, glycolysis is the breakdown of glucose to pyruvate. It's from a 6-carbon chain into 2 3-carbon chains. Glycolysis uses 2 ATP to get going, creates 4, so we net 2 ATP. We can see here as a diagram, on the left we have glucose, and on the right we have pyruvate. That's where we're trying to get to start our next step. Glycolysis is all run by different enzymes. They start different processes and keep them going. So we start off, the first enzyme produces glucose 6-phosphate, which also uses 1 ATP. So we have a phosphoryl group who bonds to this glucose on our left. The second enzyme produces fructose 6-phosphate. The third enzyme is fructose 1,6-diphosphate, and that also uses an ATP. So now, if you're following, we have used 2 ATPs, and that's all that we'll be using for this glycolysis, and we've already used them. The fourth and fifth enzymes divide up. Lysis means to split. So they divide up our 6 carbons into 2 3-carbon chains with 1 phosphate each. The sixth enzyme reduces NAD to NADH. NADH is going to be used later on in the electron transport chain, and that's where most of our ATPs are going to be produced. So it's actually really important that even though we're not producing a ton of ATP in glycolysis, that we are setting ourselves up for later production. The seventh enzyme is going to produce an ATP. And if you remember, the fourth and fifth enzymes divided it into 2 3-carbon chains. So that's happening twice. So each one produces their own ATP. So now we have 2 ATPs. The eighth enzyme moves phosphate group to a middle carbon. So right now it's bonded to the top and it's just moving it to the middle. The ninth enzyme has a byproduct of H2O. And then lastly, another ATP is produced times 2 because we have 2 chains. So we've gone from glucose to pyruvate, netted 2 ATPs in glycolysis. All right, moving on to the second step, the Krebs cycle, also known as the citric acid cycle. This happens inside the mitochondria. There's preparation for the Krebs cycle that sometimes just gets thrown into the Krebs cycle, but it's really just preparation, which is the oxidation of pyruvate, which produces NADH and carbon dioxide. So we have more of that NADH being produced for later on in the electron transport chain. So let's go ahead and look directly at the Krebs citric acid cycle. All right, here's a diagram. You can see on the left, we have our glycolysis, which just happened, and we're moving up to the pyruvate oxidation. What's happening is one of those carbons is being cleaved off, and in it we're producing an NADH. And we have acetyl-CoA. This is going to become important later on when we talk about creating ATP from fat as well. So it's going to combine with oxaloacetic acid, and here it comes down to form citric acid, which is the same citric acid that's in orange juice or lemon juice. And from this citric acid cycle, we're producing 2 NADHs, some carbon dioxide, an ATP, FADH, and there we have another NADH at the very end. So just be thinking, we had 2 pyruvates at the end, so this is producing another 2 ATPs because we had, it's happening twice. So let's move on. And now we have the electron transport chain. You can see here, so we have glycolysis, and then we had the Krebs or citric acid cycle. And this is preparing us all mostly for this electron transport chain. The electron transport chain is happening in the mitochondria of the cell. And we have NADH is being reduced to NAD positive plus H plus 2 electrons, which is, those are very powerful, or they have a lot of energy in those electrons, which is gonna go down the electron transport chain, and as it goes down, and it's going to come out with water is going to be the end product, but it's releasing energy every time it goes down that electron transport chain, which is moving. If you can see here, these where the arrows are coming through, it's moving hydrogen into the outer membrane. When it's out in there, it's going to become very acidic, and they're going to want to go back in. So these hydrogens are getting pushed up with the energy, and then they're coming back around into the ATP synthase. The ATP synthase, as these hydrogen are going back in because they're wanting to have an equal gradient, ATP is being produced through the ATP synthase. It's kind of spinning it around and pushing them together to create ATP, which is where the majority of our ATP is being produced. So those NADHs, you can see, that's providing the energy for these hydrogens to be pushed into the outer membrane. That's why they're very important. We produce some all the way back to glycolysis, and we produced some in the Krebs citric acid cycle. They're super important to give us energy to push the hydrogen, so they have to go through the ATP synthase and produce ATP. One glucose molecule has 32 net ATP from glucose. It produces 34, but if you remember, we used 2 in glycolysis. Some sources will say that one glucose molecule can produce 36 or 38, but for the sake of this, we're going to go with the exercise physiology book, which says 32. All right, now we can do ATP production from fat. This is actually, they join cycles. So one glycerol molecule produces 19 ATP molecules and 3 molecules of 18 carbon fatty acid, which will make a little bit more sense on the next slide, produces 441 ATP for a total of 460. All right, so we're going to take the fat, and it's going to go through lipolysis, where we produce a glycerol and 3 fatty acids. Glycerol breaks down to pyruvate, and then you remember pyruvate from the beginning of the Krebs cycle. You're just going to, after that glycerol is broken down, it's just going to take you straight to the Krebs or the citric acid cycle, and it's going to go through the same process that the glucose went through. The fatty acids are going to go through something called beta oxidation, which transforms the fatty acids into acetyl-CoA, which begins the Krebs cycle. And if you remember that as well, it takes us right back to where we were with the glucose. And here's a picture you can see. So it's transforming to glycerol and 3 fatty acids. The glycerol goes to 3-phosphoglyceraldehyde, which is going to go to pyruvate and the citric acid. Fatty acids, beta oxidation, straight to the citric acid cycle. And then ATP in the real world. So we might be thinking like, okay, so we have all these different systems, but how do those actually work together? So if you're sitting to your walking, you're increasing your energy transfer by 4 times. So just that little bit, sitting to walking is 4 times. Your body says, all right, let's go ahead and go. From a slow walk to a sprint, you're increasing it 120 times. Your body can only maintain a very small percentage of actual ATP. It's kind of a big molecule, and we only have about 3 ounces of that in our body at a time. So over the course of a day, your body's going to be reproducing that ATP all the time, and it's moving quickly. So the moment you start doing physical activity, the faster it's going to have to start to replenish itself. Short, intense exercise, we're talking like less than a minute, just a short burst, is going to be using a lot of ATP and PCR. That ATP is already in your body. You're just going to use up that burst. 1 to 2 minutes of exercise is going to get you to glycolysis. The glycolysis, you're going to start transforming the glucose into energy. It's not just what's sitting there ready to go. And then longer, you're going to start using the aerobic system, which is going to move into the citric acid cycle and the electron transport chain. The citric acid cycle and the electron transport chain must have oxygen to be used. The glycolysis does not, it's anaerobic, which means that it does not have to have oxygen. After glycolysis, if there is no oxygen present, then it's going to go into the fermentation, which it would produce lactate. If there is oxygen present, then it can go on into the citric acid cycle. If you're exercising and you need to produce more energy and more ATP than the oxygen can keep up with, then those hydrogen will bond to pyruvate and produce lactate, which is then where we get sore muscles and stuff like that. All right, and then here are my sources. Thank you.